May meeting. This is our last meeting until September. I am Erin Frigo. I'm the president here of the Panhandle Archaeological Society. And our speaker tonight is Dr. John C. Lohse, here to talk to us about the Calf Creek Horizon, a mid-Holocene hunter-gatherer adaptation in the central and southern plains of North America. At this time, for those of you on Zoom, I will ask that you mute yourselves, turn off your speakers just to minimize interference while we listen to our presenter. And also please be aware that we are recording this live to our YouTube channel. And with that, I will give the floor to you.
Erin, thanks very much. I'm going to share my screen, I think. Can everybody see that all right?
You're doing good.
All right, so far so good. Play from start. All right. Well, good evening, everybody, and I appreciate the invitation to speak to the Panhandle Society this evening. Erin's right. What I'm going to talk about is this title for the presentation is kind of long and awkward, but it comes from the title of a book that was recently published last year, Texas A&M Press, called Calf Creek Horizon, a mid-Holocene hunter-gatherer adaptation in sort of the south central part of the U.S. The topic, we're going to kind of spend some time talking about the book itself. It's one of the most remarkable projects that I've had the privilege of being part of. And then I kind of want to just cover some highlights. I suppose there are no lowlights in the book. It's all exciting stuff about what Calf Creek, how we understand Calf Creek, how we've come to understand it, and what this sort of body of scholarship does for us kind of moving forward. So this is the cover of the book. It's an edited volume, consists of about 22 chapters. We worked with Texas A&M Press through the whole process, and they were extremely professional, competent, responsive, supportive in every possible way. So that was a real joy to be involved with that publishing university. Of the 22 chapters, there's a ton of different kinds of topics that address Calf Creek. The book is broken into different kinds of topical sections, but we covered radiocarbon dating and chronology. We covered in different ways the geographic distribution of Calf Creek materials. There's a little bit of kind of historical information that's of significance. In there, some environmental reconstruction. There's a chapter about bison evolution and the importance of bison to Calf Creek hunters. A number of typological and technological studies that really have moved us forward in terms of how we can understand the variability that exists within Calf Creek and what that means from an anthropological and an archaeological perspective. I'll cover a little bit this evening of some of the heat treating implications and conclusions, and talk a little bit about the controlled experiments that were conducted to get us to those understandings. The heat treating technology or behavior that's part of the Calf Creek kind of behavioral bundle is one of the most extraordinary things that I've ever seen in terms of an archaic cultural pattern. So it really is impressive, especially when you think about the intensity of the heat treating behavior on a grassy plains environment that presumably is a little bit scarce of wood. So these regional studies are a significant focus. And so depending on where you are, in Calf Creek geography, a lot of the material in here may be from your backyard. And then, throughout there's some themes about cultural change and exchange through the Calf Creek period. The beginning of the book, the chapter 1, sort of presents a model that we're going to end with tonight. And I'll go ahead and go on the record at this point. Maybe afterwards, Don Wyckoff can share his views kind of about the origins of Calf Creek. I have a hypothesis about a model that we might test in the future for how Calf Creek came to be. But I can't vouch for the universally held nature of this belief. So this is what our book looks like, Texas A&M Press University. Let me encourage you to pick up a copy. This is not self-promotion. All the proceeds of the book are being donated to the Native American Scholarship Fund of the Society for American Archaeology. When I talk about this project, I have done a lot of collaborative work in my life and my career. I prefer this kind of scholarship. It's rewarding. It moves me forward as an individual and as a scholar, and I get more out of it than I put into it. And I really can't imagine conducting research and meaningful research in a non-collaborative way. I was invited to participate in this project by Don Wyckoff and Margie Duncan. A lot of what we know about Calf Creek is thanks to these individuals, their students, their colleagues, their cohort. So for me to participate, to be invited to participate was a real privilege for me. And a lot of what we're going to talk about this evening is really kind of due to the advances, the work and the scholarship, the dedication of the topic by Don and Margie and a lot of others, some of whom are on this call this evening. So I'll try not to be too nervous. But my main goal this evening, I think, when I talk about Calf Creek, is not to talk about John Lohse's work with Calf Creek, but is to kind of lift up the spirit and the nature of the volume. As you'll see, it's deeply collaborative. It's very, I think, detailed and oriented with respect to what we have learned from different perspectives and angles about Calf Creek. But this is really the result of a lot of people's contributions and collaborations over a long period of time. So think of me as a spokesperson. If there are questions about the clarity of the message, that's my fault. If there's something that you learn that's incredibly impressive, no doubt that that's because of some contribution or some scholarship by one of the many people that's included in this collection. So that's, for the record, I'm simply conveying the message about Calf Creek for where we are today. When I talk about collaborative work, one of the things that stands out about this particular collection and how it represents what we know about Calf Creek, the advances that we've made about Calf Creek scholarship, is the incredible number of people that Don brought to the project. There are a series of chapters when I talked about geographic distribution, regional studies. There are a series of chapters that Don pulled together, collaborating with individuals, collectors, hobbyists, professionals, students, former students. And the list of kind of collaborations, I think, for these different regional studies, this is a chapter that focuses on the Panhandle, where a lot of you folks are and have worked, is, I think, one of the most important and significant aspects of this particular volume. And for me, it really is a powerful reminder of the potential for collaborative work across different aisles and across different disciplines. And so this is one of the aspects of our Calf Creek project that I'm particularly proud of and want to draw attention to. So Calf Creek Horizon. This is a map from our volume, and the line is dashed for a reason. We have a good idea of what's inside that line. The boundaries could be probably redrawn by somebody else with a different perspective or based on different information. Those dots that include sites or show site locations, there are hundreds and hundreds of other sites that are not shown. So please don't get the impression that in those blank areas, across sort of upper Texas, for instance, or, a lot of Kansas or Missouri or Arkansas, that there is no Calf Creek material, because there's a lot more than what's shown. I think what we're looking at is simply here the distribution of some of, or most of, I don't know if it's all the sites that we talk about in the book, but this is what's intended to, this map is intended to convey kind of the sites that we drew from for the chapters that are in the book. And you can see a couple of pretty distant outliers. These are sort of singular, or a couple cases, a couple specimen surface finds that have been reported in the literature or to archaeologists that occur, hundreds and hundreds of miles outside of the Calf Creek sort of area, if you will think about it like that. So this dashed line covers about 500,000 square miles. If you looked at the geographic distribution of Calf Creek and compared it to almost any other archaic period cultural horizon or time period or cultural pattern, this is one of the biggest sort of archaeological horizons that we know about, that's known to science. And so there are a lot of people out there that have seen Calf Creek, as part of their assemblages, as part of their records, but for different kinds of reasons that we'll talk about. It has been a very difficult thing to kind of nail down in terms of geographic distribution and what it means and time period. But I think that we've done a good job of getting started on these topics. So what do we mean when we talk about Calf Creek horizon? So the next couple of slides just kind of runs down a list of typical traits, qualifying characteristics, if you will. And the uniformity or the consistency of these patterns that we see across this large area that I just showed you on that map is such that you can define a Calf Creek component or presence at your site based on even one of these traits. And so it's so characteristic and so consistent. These are defining characteristics or qualities that we use to sort of mark or define a Calf Creek horizon or time period. And I think most people in this presentation, this call, know many of these or most of these, but this is sort of a trait list that we pulled together. So these deeply basally notched, there's that specimen on the top is 2 photographs and 1 drawing. That's 1 specimen. The deep basal notches is very characteristic, and we're going to talk a lot about what that means and a little bit about how it's accomplished. That notching is a very risky napping strategy. And so not surprisingly, people practiced it a lot. And we find these notching practice pieces all over Calf Creek sites. They're very distinctive for what they are. The notching flakes that come out of these practice pieces, and especially the finished bifaces, are so distinctive that the debitage itself, like Clovis overshot flakes, these notching flakes can be characteristic or diagnostic of the Calf Creek component. The notching strategies, they're so important to Calf Creek point production or biface production. Also, not surprisingly, come along with some pretty characteristic patterns of failure. The photo on the bottom left on my screen is a Andice point failure that was broken during that notching, and that curved sort of fracture plane that runs from around my middle finger up to the top of the point. If you see that, even if the point has been reworked, if you see that with that squared stem like that, you know that that was broken during notching, and you can talk about Calf Creek. I shared that photo with some folks that I work with that are a little bit less familiar, and they thought it was witchcraft. It's not, it's actually science and lithic technology, but even the breakage patterns and the failures are characteristic of Calf Creek behavior. There we go. Very highly skilled flint napping. And this is a statement that's true, that defines a lot of archaic and Paleo-Indian period assemblages and traditions. But for Calf Creek, the riskiness of the deep notching is such that it was a kind of a, when well done and well executed, a flamboyant, kind of a showy behavior. And this is one of the most, I think, symmetrical and exquisite examples that we have of Calf Creek finished bifaces in the book. And so not surprisingly, there's probably a social or a cultural value to these bifaces, and the expertise, the craftsmanship, and the skill specialization that goes into their production ought to be seen or thought of as a defining trait for Calf Creek behavior. Calf Creek peoples were bison hunters. Do Calf Creek peoples, do they kind of extend before and after periods of bison presence? We don't really know that. And when I get to the dating part of this paper, we'll kind of talk a little bit about those implications, or if there's some questions about the connection to bison that come up later. I want to hear those, please, from you. But we see bison remains in Calf Creek assemblages whenever they're well preserved. And so surface finds, of course, not often come with bison, unless you get lucky and you're walking down the riverbed near Tulsa, Oklahoma, and you find a skull cap with a Calf Creek point stuck in it, or you're digging a swimming pool in Stinnett, Texas, and you find a bison with a Calf Creek point associated with it. But for most of us who don't have those kinds of experiences, when we're in sites that have a little bit of stratigraphic integrity, bison is all over the place. And helps define Calf Creek components, and of course has a lot of implication for Calf Creek cultural behavior that we'll talk about. Exotic material, yes, material moves, has been documented many hundreds of kilometers away from its source areas in some Calf Creek components. Heat treating, talked about that a minute ago, and we're going to cover some of that in a little bit more detail. And caching is that last point down at the bottom. The recovery of caches, cached bifaces, by that I mean 2 or more bifaces sort of in the same fine spot that were deposited in the prehistoric past. Presumably they intended to come back for those, but that's kind of an open question, really. There's not well documented caching behavior in all prehistoric time periods. To my knowledge, it's one that is though closely associated with time periods during which people, their mobility ranges increased in size as they covered larger and larger areas. And so we do see caching. It's not as commonly reported for Calf Creek, but there were a couple of caches reported in our volume that I want to show you because they're just so amazing. But it is an important behavior, part of the behavioral program for Calf Creek, I think, that really kind of helps us to understand how these people were moving across the landscape in long distances in some cases. Excuse me. So what's in a name? Calf Creek is deserves to be sort of the recognized standard bearer for this cultural package and a lot of the technologies that go into it or that it's associated with. The truth is, in the history of scholarship and research, what we know today as Calf Creek has kind of evolved over time. We know from Jack Ray and Neil Lopino's presentation and chapter in our volume, Lee Adams in 1958 found some of these deeply basally notched points in his work in Missouri. At that time, didn't name the type, but you can kind of see right away, of course, how characteristic and how standardized they are. And in 2022, anybody would look at those and understand exactly what they were. As the first reported finds, scientifically recovered finds, it may have been a little bit harder to make sense of those. Around the same time, and not connected to Lee's work, Don Dixon excavated some similar specimens from Calf Creek Cave, don't say that real fast, in Arkansas. And later he did use that site name Calf Creek to define these points. We were fortunate enough to get a chapter, a kind of an authentic write-up of these type specimens from Calf Creek from Don Dixon to include in our volume. So these type specimens are represented. Around the same time, a couple years later, perhaps, in Central Texas, a guy named Bill Sorrow and some colleagues were conducting some salvage excavations associated with the Still House Hollow Reservoir project. And they recovered in Bell County what they called Bell Points. And those are the ones that are circled in red. Those are some of the type specimens that Sorrow et al. Recovered from their project. Again, you can recognize right away these characteristic sort of deep basal notches. He called those Bell Points and offered that as a provisional name. One of the chapters in our volume is a more detailed, kind of thorough, if you will, type description by Elton Pruitt that kind of standardizes some of the traits, the metric ranges, some of the variability that we see within the Bell type category. So those three studies really are kind of the pioneering ones and helped get Calf Creek and what these kinds of points look like into people's minds. In the early 80s, Elton used an existing collection that had been recovered by, excuse me, J.E. Pierce at the Galt site that was held as a collection at the Texas Archaeological Research Lab in Austin to define the Andice point type. And so obviously Andice points had been seen and recovered, observed a long time prior to 1983, but in 83, this particular type, as different from Bell, as different from Calf Creek, was given a type name based on existing type collection. And we were fortunate enough to get permission from the journal Lithic Technology, or maybe La Tierra, I beg your pardon, where Elton first published that study to reprint that in our volume. And so we have some original type descriptions for Andice, for Bell, and for Calf Creek included in the book. And so that's a feature that we're really proud of. But this just begins to kind of get to a little bit of the typological variability within Calf Creek. And today, I think many of us use the term Calf Creek series. That word series is sort of the key phrase in this, the key word in this phrase. And we use it to include or to refer to a group of morphologically and technologically related types. And so it is important and worth the trouble to kind of split hairs and talk about Andice versus Bell versus Calf Creek. But in a lot of cases, for expediency, the Calf Creek series is a term that's intended to include those three types. As it turns out, it's intended to include other types as well. So most of the usage of Calf Creek series in our volume refers specifically to Bell, Andice, and Calf Creek. Those are sort of the three founding members of the series. Cossatot River is a related type that I was completely unfamiliar with before I had the opportunity to participate in this project. And I'm going to include the Laguna type. Those of you who follow kind of Tom Hester and Turner and Hester and McReynolds et al. Know that this type was defined a few years ago and it includes or refers to these bell-like points that have the outward flaring ears. Elton Pruitt included those specimens in his bell chapter. I think there's a little bit of disagreement about whether the Laguna is its own type. Elton saw those as resharpened or reworked bell points. So I just want to acknowledge that Laguna type name is out there, and sort of leave open the observation that there is a lot of very important and valuable work that needs to happen to kind of refine our typological studies and our typological categories within the Calf Creek series and Calf Creek research domain. But these Cossatot River points are pretty fascinating and pretty interesting, are characterized by these deep basal notches as well, but those stems have a kind of a characteristic indentation on the base that a lot of the other types, some of the other types don't have. In terms of the geographic distribution, again, these lines are all dashed, and so this is approximate, also because PowerPoint just makes either ovals or circles. But generally, some of these ranges do overlap, but not completely. In general terms, Cossatot River, occurs to the north. Bell points occur to the south, even as far south as into northern Mexico. Andice was found at McFadden Beach, which some of you all know is on the coastline of Texas. About 6,000 years ago, the coastline was quite a bit farther out. And so if we drew a circle for Andice distribution, that should go out of the Gulf waters to include continental shelf that's now submerged below rising sea levels. But some of this, one aspect of the typological sort of approach to this work begins to get to variability within the Calf Creek horizon geography. And I think this can lead us to some pretty important anthropological questions. So what is the relationship within this Calf Creek series? We talked about just the different type names and so forth, but what do we get from that? It was proposed early on, I think, that within the Calf Creek series, these different types really just represented or showed us one general point type that was in different stages of having been resharpened. I think this is a fairly widely held belief early on. Some of Elton's work is based on defining types and included some fairly basic measurements. Sergio Ayala's work, that's really well represented in this volume, brings this question really to the surface and shows that no, that's not quite the case. They're not different stages of having been resharpened, but based not only on stem dimensions, and that's what we're looking at here. And you can see that the bell and the Andice do not overlap, but hardly at all. Calf Creek is in the middle, but also very distinctive. Some of these stem dimensions can be used to separate out bell points with 100% confidence from Andice points, from Calf Creek points. But Sergio's work goes beyond simply measuring stems to kind of define or help us outline or characterize mental templates, associated reduction techniques, approaches to notching, the tendency for those notches to be a little bit deeper, a little bit more shallow across these three different types. And so his work is really critical, I think, and the best that we have so far that I've seen at drawing out not simply morphological differences, but some of the technological and mindset differences, inferred mindset differences that can be associated with what he calls Andice technology, Calf Creek technology, and bell technology. And so what we see, based at least on this technological work, is that these really are not overlapping types, but they are regionally distinct, and they're valid categories, each unto themselves. So today, I think, based on this and other work, the best horizon or the best understanding for Calf Creek is to kind of view it as an archaeological horizon. And so that's a manifestation that covers a fairly broad area within a very defined time period, within which we have a lot of very widely shared and broadly shared behaviors that are so consistent that we can see them from the north to the south end of this region. But within which there's a lot of variability that represents localized expression, localized traditions, localized patterns of behavior. And so for me, working with archaeological horizons kind of allows you to go up and down in terms of geographic scale with temporal precision and kind of compare and contrast in some really important and exciting ways. So when we talk about Calf Creek horizon, this is what we're talking about. So I want to talk just a little bit, these next sort of series of slides are about a little bit of the regional variation, not typological, but behavioral. Heat treating, I mentioned that kind of earlier on in the talk, and an example of what we see or how we can measure or what we know about the movement of materials across long distances. In this regard, two sites in particular, Grouse Creek and the Cubic site, and these are at the very southern end of the Flint Hills region that stretches across most of central Kansas into northern Oklahoma, are probably two of the most important Calf Creek sites that we're ever going to have. Before the talk, I debated about whether that statement was a meaningful one. These are two of the most important Calf Creek sites. I think it is. They were significant both in terms of defining kind of earlier in impactful Calf Creek research, some of the basic parameters that we have, to understand heat treating, chronology, bison association, reduction technology, and so forth. But for that reason, they are lasting and important studies. But Grouse Creek in particular, I would be surprised if we ever see anything like this amazing assemblage again. So Cubic, excavated starting in 1996 and that work was done by Don and Margie and several others, included a number of 2 by 2 meter units. I'm just lifting out a couple of the highlights to kind of support the point that I'm on right now. A few features were found. Feature 5 is a dense kind of cluster of flakes. There's over 380 of those. And you can see on that slide, they're all kind of pulled out and sorted into categories. And one of the things that stands out is that they're all rosy pink in color. And most of us know that rosy pink in color means that they were subjected to heat treating. I should have mentioned about the book, I beg your pardon. When you buy a copy, one of the things that should be impressed by is that it weighs about 1,000 pounds, because the press had to print full color artifacts, illustrations, maps, photos, all that stuff is on full color. So the weight of the paper, the quality of the paper to kind of withstand that color printing makes it a very hefty volume. So anyway, heat treating from Cubic features behavioral implications for all that stuff. And importantly, this is one of the very first sites that we got that had some radiocarbon dates that allowed us to kind of begin to nail down Calf Creek in time. So this is what heat treating looks like from Cubic, and also a little bit of the preview of the radiocarbon stuff. And I'm going to return to radiocarbon in a little bit in this talk. Just a little bit to the north, though, a little bit later in time. This is over about a 10-year period from the early 2000s. The Grouse Creek site was surface collected, I think never scientifically excavated, by a gentleman named Travis Long. Brought it to attention. Over 800, that's our true number, Calf Creek artifacts were recovered. That includes over 320 points. I would call those finished. And I've got some photos of some of those, and what you'll see is that they're finished, in fact, but they're broken and resharpened. And so at that point of discard, we can understand Grouse Creek as a base camp that people returned to and produced bifaces and created, bifaces and preforms and finished points to kind of retool as they kind of reconvened and gathered themselves and their thoughts and rested up to head back out for the next seasonal hunt. And so it's a base camp. It's a retooling station, but one of the amazing things is not simply the size and the diversity of the assemblage that came from Grouse Creek, but how extensive and well documented the evidence is for heat treating in a very intensive and intentional way. 94+% of the material is from the Flint Hills area itself. So small percentage, 5 or so percent is exotic. That's all been tabulated and categorized by source and by distance. And what you can see is that even in a sort of a chert-rich area like the Flint Hills area, other materials are being sought after, being obtained, and being brought back to these areas from as much as 800 kilometers away. And so we begin to get a kind of an appreciation for the size and the scale of the annual mobility, the settlement mobility for Calf Creek hunters, even in, like I said, chert resource-rich areas. So I'm going to flip through a few of these images, and I swear that they are a little bit more impressive in the book, but the materials from Grouse Creek were sorted not just technologically, but also by color gradation and variation. And those color gradation sort of increments are 25-degree intervals, and we'll talk about how we know that in just a minute. But they can show you, just sort of slowly scanning through these, The ranges of reduction, the stages of reduction that we see in some of the bifaces. It's a good example of how some of these points, like I said, are not necessarily broken during production, but were broken during use and then brought back to this camp to be discarded and replaced. But also some of the variation in the color ranges, and the pinks become a little bit more intense and rosy as you move sort of upwards in temperature from 600 to 625, from 625 to 650 degrees. And that little table that's down there on the bottom left just kind of helps to show what percentages of the collection fall into these different temperature gradients. Okay, so upwards of 700 degrees, upwards of 725. And when we get to these temperatures, this is controlled heating. Okay, and so the implication of this work, this is work that was driven largely by a gentleman named Paul Benefield. This is controlled heating. So this is a targeted range. This is not accidental. We can see accidental sort of failures, if you will, from cooking events that they got too hot or they got hot too fast, results in certain characteristic kinds of failures and color characteristics that are associated with those. After documenting or helping to document the Grouse Creek material, Paul conducted some well-controlled, well-documented heating experiments where he kind of reconstructed some of the conditions under which he imagined Calf Creek bifaces were cooked, if you will, or baked. Paul's also a very accomplished flint knapper, and so a lot of the bifaces, all the bifaces you see that were involved in those studies, he produced himself. He was also involved in replicating Calf Creek technologies, biface production, basal thinning, and so forth. So from Paul's work, what we get is this incredibly useful table that tabulates optimum ranges or temperature ranges for different kinds of material. I imagine a resource like this is going to be useful for Calf Creek archaeologists, across the South Central United States for the rest of time. But one of his conclusions that is so, I think, impactful to me has to do with the amount of time that's required to carefully control, one of these heating events or these chert cooking sort of episodes. In his estimation, I think, to kind of slowly bring the temperatures up to their ideal range, which is around 600 degrees plus or minus a few, to keep it at that steady temperature sort of constantly over a long enough period of time to extract enough of the moisture from the chert, and then to very slowly and controlled way decrease the temperature of that the heat treating event. That can take somewhere between around 20 to 40 hours. It consumes an incredible amount of wood. It takes an incredible amount of time. It reflects an incredible amount of sophistication and understanding of the requirements of cooking stone, if you want to think of it like that, to control the heating, maintain the temperature, control the cooling. And it also reflects a pretty deep appreciation for the beneficial impacts of heat treating, control heat treating for Calf Creek production. So can they make Calf Creek points without this heat treating sort of elaborate technology? Maybe. We're going to see a lot more failures without this careful heat treating. So it's clearly a strategy that was adapted to help ensure or help achieve the success of these deep basal notching attempts and the biface thinning attempts that are sort of make up a risky part of the Calf Creek strategy. Hashing. This is one of the most amazing sort of collections of bifaces I've seen in my life. 1, 2, 3, 4, 5, 6 bifaces reported from the very far kind of northern part of north central Texas in Montague County. This is far from chert outcrop areas. Sergio documented this when he was traveling around the Calf Creek area documenting bifaces. If you knock on enough doors, apparently people have some Calf Creek caches that had not been previously reported to science or widely reported to science, if you will. So Sergio got his hands on these, Sergio Ayala did, and included those in his detailed characteristic studies for reduction, for andice technology, for notching and so forth. The longest of those in the top left is over 20 centimeters, if you think about the size of these things. They're a little bit worn and a little bit resharpened. Some of them have these sort of odd notches along different parts of the blade. And that's kind of hard to understand from a utilitarian perspective or point of view. And so it seems possible that this cache, in addition to representing well-representing andice reduction technology, is giving us a little window into some non-utilitarian behaviors or mindsets of ancient Calf Creek peoples. A little bit less exciting, but nevertheless, down in sort of South Central Texas from Wilson County, the Knockinut cache has come to light. One of the things that, one of the points I want to kind of make about these two caches, and there are a few others, you know, like I said earlier, Calf Creek caches are not as well known as we would like or as we need. These two caches show us different stages of reduction, biface reduction. The basal thinning on these three bifaces is really important for setting up those deep basal notches to set those sort of entry points up to as for success rather than setting them up for failure. But geographically where these two caches came from within the state, they're not close to chert materials, chert outcrops. And so certainly not source areas that that allow people to have recovered cobbles that are this big in size. And so they again give us a little window into the geographic range and the mobility of Calf Creek peoples, as well as some of the technological stuff. Radiocarbon dating. One of my favorite topics. Our older chronologies for Calf Creek, you know, so we've known Calf Creek scientifically for 70 years, plus or minus. Some of our chronological models had Calf Creek sort of spanning maybe as much as 1,000 years, which is pretty amazing when you think about it. There's lots of reasons for that, you know. The compression, the sort of the mixing of site components that were scientifically excavated decades ago. You know, I think application of pretty imprecise dating approaches or techniques contributes to this. The most common and cheapest, most cost-effective dating technique available to archaeologists is dating by association. It's free. I think dating by association has been used pretty widely to kind of estimate a range of Calf Creek stuff. So if you find Calf Creek points with Pedernales points or with early triangular points or with you know, something that's a little bit earlier, the assumption is that maybe those things all go together. So what I think the outcome of that has been the production or the circulation of these, what I call long chronologies. 1,000 years is a long time. And in my own work, what I wanted to know was like, is this really true? I mean, how can we bring some focus and some resolution to that? And so partly as a result of that, we sort of began to look into the possibility of a short chronology and wondered what would happen if we kind of tightened some of the parameters that we use to date Calf Creek so that we had more confidence in the results that we were getting. And so we started dating bison bones, and I don't want to get into much about the chemistry and the requirements for precision bone dating, but there's some purification techniques that need to be conducted to your bone sample before you submit it for dating to make sure that all the exogenous is a terrible word, the intrusive organics that have leached into bone material in the archaeological matrix, that you get those out, and so that you're dating actual, you know, collagen, protein, amino acids from the bison animal itself, rather than a bunch of humic acids that have leached into it. So this is one approach that we used, and this is some of the important work from the Kubik site. If we can find short-lived organisms, nutshells is a good example that were unambiguously associated with Calf Creek deposits, we can kind of lift those up. So what we came up with was kind of an example of a preferred hierarchy for samples, selecting samples, pre-treating samples, XAD, purified bone collagen is a mouthful. And we began to kind of filter the published record of radiocarbon dates and selected these out and left some of the others behind, just to kind of see what would happen to our bison, our Calf Creek chronology. And you'll see the result is that we're not talking about 1,000 years in time. I can't find under those parameters, right? And so if we look at this preferred hierarchy table, using this filtering system, we cannot find a Calf Creek radiocarbon date that really touches 6,000 calibrated BP. Those dates across the bottom are all calibrated, so they're calendar years, like what we live in now. The oldest one is maybe, you know, at 2 standard deviations calibrated is about 5990 or 5980 or so. The youngest ones, again, using this sort of preferred hierarchy of samples, rarely comes before 5,700 BP. And so what we're talking about is, you know, maybe a range of 250 years from about 5,700 plus or minus to 5,900 plus or minus. 21 dates. Is that a lot? No, that's not a lot. especially if you look at, 500,000 square miles. And so clearly what's needed are more samples carefully selected from well-documented contexts and deposits. If we find bison in Calf Creek components, which is not all that difficult to do, submit those materials for dating, but they have to be XAD purified samples first. The offset difference between one of those well-purified samples and a not well-purified sample can be 200 or 300 or 400 years. And so again, the difference between, the approaches is the difference between sort of reiterating one of these long chronologies or getting a more focused short chronology. Really an exciting kind of element or study that we were able to include in our volume is a recent data recovery project that came from Northwest Arkansas. And within that chapter, we had a couple of new radiocarbon dates that are not included in this particular table, right? But these two sites, Hudson West and Hudson East, essentially are alluvial deposits, terrace deposits on two sides of Spring Creek up in Benton County in northwest part of Arkansas. And Flat Earth Archaeology is the firm that conducted that work. Sheen Chowdhury was a lead author on this study. Did a really masterful job of kind of bringing together all of their soils data, all of their contextual data, their church sourcing data, typological analyses, feature discussion. It's a really significant bit of scholarship to have included that brings a lot of different kind of detail to what generally is not a well-studied part of the Calf Creek area. But they were able to get a couple of radiocarbon dates. And so those are not included in that table that I just showed you, but those two dates are represented by this red bar that I'm overlaying across the other table. So again, carefully selected by these kinds of sampling protocols, if you want to think of it like that, do not disrupt the model. So the sum sort of conclusion at this point is that all the quote unquote reliable dates, and again, those are ones that we've selected based on those criteria, consistently without variation, fall from 5950 or so to about 5,700 years ago. Interestingly, again, it's a very small sample. What we see is that it's only by a few decades, but some of the older dates are in the south of the Calf Creek area, and some of the younger dates occur to the north. There's a lot of overlap, right, in that statement right there. But it is true that the oldest bison dates that we have for Calf Creek components are in the southern part of the Calf Creek area, not the northern part. And this is not exactly what I would have expected, to be honest with you, before we started the study. So we're going to land this plane now and kind of talk about a hypothesis for the origins of Calf Creek. And this is a model that kind of brings together a lot of this information that we've talked about, a lot of the other information that's in the volume that I haven't talked about. And it kind of puts it in the context of South Central grassy plains ecology, puts it in the context of global climate change that long ago, but kind of anchors, I think, some of these observations and data points in terms of what we knew and how we can put these together in a model going forward. So from radiocarbon data, we just reviewed that. We know that Calf Creek was a very brief period. We're not talking about 1,000 years. We're not talking about 500 years. It's 250 years. I wouldn't argue if you said 260 years. I would argue if you said 400 years, but the truth is that we just need more dates to figure this out. But we know it was very brief. From isotope data, stable carbon and nitrogen isotopes, and this is some of the bone chemistry that comes, there's a byproduct of the bison bone dating work. From isotope data, we know that Calf Creek was a very cold period and a very arid period, cold and dry, okay? This isotope sort of bivariate graph, stable nitrogen on the vertical axis, stable carbon on the horizontal axis, is from Casey Carlson's work and Lee Bement's chapter talking about bison evolution and bison sort of isotopic paleoecology, if you will. Those two scholars, of course, have conducted a lot of research on bison dating, isotope studies, distribution patterns, cultural behavior, Folsom jumps. I don't know how they get so lucky to have so many bison jumps. But they overlaid this kind of that black plus sign is the isotope ranges for my own Calf Creek bison dating work over some of their isotope values for Folsom, Archaic, and other Paleo-Indian sites. And you can see that C that the Calf Creek stuff overlaps with is their Cooper site. So this is Folsom period stuff. And so based on the isotope stuff, we know that Folsom was about as exactly cold and dry as Cooper period within the Folsom time period. So this much we know, right? And if you put this in context of sort of global climate change, you don't have to pay too much attention to this complicated graph, but those green sort of vertical bars are periods of rapid cold events that have been globally defined based on pollen studies, isotope studies, speleothem studies, lake sediment core studies from around the world. So globally, we know that temperature changes rapidly during these green intervals, and it gets cold, and it gets cold fast. What triggers those is a whole separate discussion. It has a lot to do with sort of solar radiation, in some cases, explosive volcanic events and other factors. Nevertheless, starting around 6,000 years ago, we see the beginning of the onset of one of these cold events. This is significant, I think, for our understanding of where Calf Creek comes from. So when we begin to kind of chart this out, what this looks like or would have looked like in continental North America, we know that colder temperatures, the cold air comes from the poles, and that those temperatures sort of migrate, if you want to think of it like that, southwards towards mid-latitude regions. And so as those colder temperatures sort of migrate, so-called migrate south, there's a kind of a time transgressive progression of colder temperatures. And the same is true in reverse. As those cold spells go away, it gets warmer south, and then gradually the warm climes migrate northwards. Nevertheless, as the colder conditions come south, so too come the short prairie grasses that are more typical of northern latitudes, C3 grasses. So as those grass habitats migrate south, and I think one of the studies that I wish that we had been able to find and include in our chapter would have been kind of a grass paleoecology study that talks about how quickly grass habitats migrate during periods of climate change. As the habitats come south, the bison comes south. Okay, so this part of the model is fairly straightforward and elegant. We don't have a lot of connecting dots data that help us kind of reconstruct these pathways and these migration routes. But this is the interval during which bison occidentalis comes from bison antiquus. That probably starts happening prior to Calf Creek, but what we know from cases in Lee's chapter and other studies, paleontological studies, is that Calf Creek hunters hunted bison occidentalis. They didn't hunt bison antiquus, and they didn't hunt bison. And so in here, somewhere in this bison ecology component of the Calf Creek story is a pretty fascinating chapter, if you will, about bison evolution and bison ecology. And I think it would be exciting to see this get worked out in future studies as well. But I think that the Calf Creek interval is somehow connected to this evolutionary sort of step for bison, for the occidentalis to have emerged from the bison antiquus. Don never shot me down on this, and Margie never shot me down on this. So if they don't agree, that's fine. But we talked a lot about where Calf Creek technology came from. And we looked around for suitable precursors and antecedents to Calf Creek technology. And we can't find any. The best candidates that I can come up with are what have been defined as a kind of a corner notch tradition. So this includes a series of types like Merrill, Martindale, and Bandy that occur in Central Texas, South Central Texas, that have those sort of incipient notches. The angle of entry is different. Obviously, there's a corner notches and not basal notches. The thinning nature of the biface technology is a little bit different, but here's a technological model of behavior that's in place that provides perhaps a suitable candidate if we're talking about where did Calf Creek come from. And really one of the biggest changes that would need to have happen is simply take that basal notching sort of angle from the corner up to the base, right? And so this sample that we have on the right-hand side of the artifact photo, the kind of the rickety one that's a little bit resharpened, there's a bell point. That's one of the oldest sort of in situ bell points associated with dates that we have. And so for me, the best candidate for a technological ancestor to Calf Creek, it comes from the southern part of our Calf Creek area, and it has to do with these corner notching traditions, as those may have been converted to more kind of vertically aligned basal notching traditions. Talk about suitability of candidates. Munkers Creek is well understood, not really well dated. This is from Michael Steitz's chapter from Kansas. And there's a lot of different sort of probability distributions that are overlaying each other on the kind of the graph on the bottom right. But that big tall red line is Calf Creek summed dates, and the yellow one is Munkers Creek. And you can maybe hopefully make out that the peak for Munkers Creek is just prior to Calf Creek. Chronologically, Munkers Creek, is in the right position to have been an ancestor or precursor to Calf Creek, but you can just see, the finish points are slender, barely any shoulders, no notching whatsoever. They're just not, a candidate. They don't have anything in common with Calf Creek behavior. And so we need to find other candidates for technological precursors or ancestors to Calf Creek. But I think so far the best that I think we can do is the corner notch tradition that I just talked about. So I envision a scenario where habitats change, climate change, cold temperatures change, bison came into the region, and that new prey resource sort of came into contact with cultural and technological behavior that was already kind of pre-adapted with some minor transitions and adjustments, became Calf Creek, and that technological behavior kind of moved or migrated back upstream, if you want to think of it, from south to north into Calf Creek areas. This model accounts for some of the older dates we have in the south. It kind of connects Calf Creek technology to what was in place, at least in some regions prior to that. But the fact is that this is simply a model. Hopefully we can get it on the books and do a lot of robust testing in future decades. But this is my best guess for where Calf Creek may have come from. And it helps to kind of also account for or leave space for a lot of the behavioral variation that we see within the total Calf Creek area. So conclusions, I see Calf Creek as very much Paleo-Indian-like. It's a thin horizon, well controlled chronologically, covers an enormous area, focused on extinct fauna. They're not Pleistocene fauna, but nevertheless, they're extinct fauna, the Bison occidentalis, very much like a Paleo-Indian, like a Folsom, like archaeological horizon. Bison focused. Mike Quigg and I used to kind of talk about what he saw as my over-reliance on the bison dates. And that's true, that's all a fair point. Are we missing kind of a post-bison Calf Creek sort of tail that extends, for another 100 years or 200 years or something? Maybe so. But I think that's an important question that needs to be asked and answered using reliable data. But for me, one of the biggest takeaways is that we really know so much more about Calf Creek than we ever would have, thanks in very large part to some of the research collaborations that Don and then Margie and a lot of people in this call were able to kind of pull together and were committed to. And so for that reason, I want to say thank you, but I also want to say thank you for the opportunity to share some of these thoughts with you and some of the highlights of our Calf Creek volume. So thank you very much.
All right, thank you, John. Do we have any questions? Yeah, okay.
So John, I just want to say, excellent presentation. I thought you really pulled everything together really well. I'd like to hear you talk a little bit more about kind of these kind of similarities that you see between trends that we see in the Paleo-Indian period in terms of like caching during Clovis times and kind of the risky technology in terms of like fluting that you also see in kind of the deep basal notching with Calf Creek, and the whole idea of kind of the demise of Paleo-Indian craftsmanship. How do you see all that kind of fitting together in terms of with like long distance mobility and kind of these sorts of trends that you kind of hinted at a little bit in your presentation?
So that's a lot, Scott. I think the shortest answer that I can come up with is also the one that I sort of believe in most deeply, and that's bison, right? The bison resource is so central to so much of the behavior that we're looking at, and I think is the best way probably to kind of connect some of the Paleo-Indian behavior that you alluded to, sort of the riskiness, the long-range mobility, The caching, I think goes with the long range mobility as you're sort of going further abroad. It's a risk mitigation strategy to kind of help ensure or promise to have available lithic resources, essentially by sort of pre-reducing these bifaces to certain stages and then caching them. You're essentially extending accessibility of that lithic outcrop further afield, right? And so that assumes that they're deposited with the intention of going back to them. That's, I think, similar to or in line with the current understanding of Clovis caching behavior. The same questions kind of have been raised and discussed about Clovis caching, like what's the purpose of those? We see bifaces reduced into multiple reduction stages, if you will, in Clovis time periods. We don't have enough examples of Creek caches to know if the same thing is true for them. I only showed you two. There's probably only just a couple others that were included in the volume. But I see the caching as a component of the long range mobility. I see the, we'll call them the requirements, but really opportunities, maybe a better way to think about it, of hunting bison and how that draws people out across a larger geography than non-bison hunting. If you reconstruct, how far afield bison herds go compared to white-tailed deer, white-tailed deer can live its whole entire life, in a certain county, if you will. In contrast, like the bison, even bison, like, late Archaic period bison as reconstructed through isotope paleoecology, hundreds of kilometers, and those numbers in terms of rounds that they migrate, those ranges get bigger as you go back in time. And so if you're a bison hunter compared to a white-tailed deer hunter, you're going to see landscapes and people that you've never seen before that are hundreds of kilometers away from your home territory. And I think I see that sort of reliance on bison and the mobility requirements for being a bison hunter as sort of drawing people out across a larger social landscape and fomenting or creating a context for increased exchange, increased interaction, increased exchange of ideas. It's very difficult for us to kind of layer into that what sorts of social values or belief systems, may have been part of that behavior, but it's not coincidental that we see more riskiness, more showing off, more, I don't want to say prestige signaling, but, we do see things in lithic technology that accompany high risk sort of profiling behavior, signaling behavior that goes along with the bison hunting. So hopefully that's enough of an answer, Scott. I mean, archaic, it's in the Archaic time period, but a lot of the behaviors look Paleo-Indian, and I think it has everything to do with the reliance on bison.
Okay, thanks. I think that's an excellent interpretation.
Thanks for the question.
All right, well, if there are no more questions, thank you so much, John. That was a great presentation and we really appreciate it. Thank you.
I appreciate the opportunity. Thank you very much.